the balls are. Okay? So, did you see that?
Yeah.
Super exciting. Okay, so I'm going to roll this one in. I know, the lamest demonstration ever. Okay? But, I mean, in terms of like an energy transfer demonstration, I get a sense like that energy can be transferred through these collisions of the balls. Does that seem okay? All right, so here's what I'm going to do now. Okay? I have back here a magnet. Okay? This is a series magnet for series magnet people. Okay? All right, and what I'm going to do is here, okay, here. All right? Got it? And now what I'm going to do is I'm going to roll my ball in. Now the thing is, like, these balls are all free to roll by themselves, but the magnet is like sitting on the track. You see why that might be a problem? Okay? So I'm going to roll this in.
Oh!
You shot it.
Wow.
So, that's weird. Tyler, that is a discrepant event demonstration. Okay? Where did the extra energy come from is the question. You see why that's a question?
Yeah.
Okay? You see why that's a question? I think that's like a legit question. But we'll get back to that. Okay? We'll get back to that. The board's magnetic. Here's another one. So this is a popper. Okay? It's a little different than the popper used earlier today. The poppers used earlier today are called dropper poppers because you can turn them inside out and just leave them, right? And they'll just sit there. Or you can turn them inside out, drop them, and they'll go sometimes. But this one's called a table popper, so I'm going to turn it inside out. I'm going to put it on the table. And it goes. Is that cool? So, did you see some evidence of some energy somewhere? Okay? So I turn it inside out and I put it on the table. If we take a snapshot of it right now, where's the energy?
No.
Is it okay that it might be in here? Do you have evidence of the fact that it might be stored in here? Right? I deformed it. Okay? Do you see how the themes are working their way through and we're seeing them again and again? You see how this works? What happens though? I put it on this table and does it go? It totally goes, right? Like it leaves this table moving fast enough to get all the way up here, yes? So right as it's leaving the table, do we see evidence of the energy? What's our evidence of the energy right as it's leaving the table?
Moving.
Is it moving fast? It's totally moving fast, right? But what we know is if I take this and I throw it up in the air and it comes back down, what do we know about its speed at the very top of its path? Check your neighbor on this one. What do we know about the speed of the object when it gets to the very top of its path? Check your neighbor.
Yeah, because it's no
Well, we kind of saw that with like the cars when they change direction, right? That moment where they change direction, so it's changing direction, going from up to down.
Towards what? And this what you said.
It changes direction.
All right. Do we have a consensus understanding? If I take this and I throw it up in the air, whoa, not like that. I'm going to throw it straight up, and it comes straight back down. What's true about the speed at the very top? Is it 0? So it slows down to a stop at the top, and then speeds up on the way back down. Here's my problem. As we watch the same thing happen here, okay, that was not a good one. That was an excellent one. You're like, I didn't see a difference there, Don. If the energy is stored in it when it's inside out, stored in the popper, then it manifests in the movement. When it gets to the very top, it's not moving anymore. Where did the energy go?
being stored.
Okay? Maybe he says it's being stored. I don't mind that as an idea. The problem is, you must either name where it's stored if you're going to say it's stored and or how you notice it. You see why this might be a problem? You with me on that? So what we're trying to do is we're trying to figure out, now, and tell me why you think it's stored as opposed to just gone.
Because there's nothing to notice, so it has to go somewhere.
Well, it has to go somewhere.
So that leaves
Why
storage.
does it have
But
to
for
be-
the noticing, like, it's changing direction, so it's not just stopped for good, it's changing direction. It's doing something.
Fine.
I think maybe it was moving and then it wasn't, right? So
Yeah.
it had to go somewhere, right?
Well, in my mind, it has to be stored somewhere, and we're going to contrast that with something else in a moment.
And then it started moving again. So the energy came back.
So I think it has to be stored because in a moment,
It's going again.
in a moment we're somehow getting it back. We're going to contrast it with this. This is just a little wood block. Okay? I'm going to pull this back against here and I'm going to let it go. Super engaging demos. Was there energy stored in the rubber band? Did you see the block moving? So it's manifesting in the movement, and now, what happened?
It's stopped.
It stopped. So where's the energy now?
It's gone. It was stopped.
Yeah, you used it.
It's
We
warmer.
Again, we have to say, like, how do you notice it, or where is it stored? And this is in contrast to this demonstration, because I would say that I like stored in this. Ah!
That's better.
That was bad. That was definitely a bad one.
I know that's better.
Yeah, hit me on the way out. Go! Because it starts to come back down. It's speeding up. We're getting more energy back, right? This one, somehow it's just gone somewhere. We don't know where it went, but it's gone. You see where I am on this? Okay? All right. Let's be serious now. So, one of the things about these cars, one of the things about these fancy cars, whether you get them from Pasco or Vernier, that I like, they have this little spring plunger on the front, okay? So you load up the spring plunger, and then you press the button, and whammo! Does that sound good? So I'm going to load up the spring plunger, I'm going to put my car here, not that car. Put my car here, and if I hit the plunger, what's going to happen? Do you have a sense of it? Are the cars going to move away from each other? Okay, let's check. How'd that look? Good? Did it do what you expected it to do?
Yeah.
Let's take it in an energy context. Where's the energy stored now? It's in the spring, true? And you notice that because I had to load it, right? I had to push it in and like, stop it. And then, where's the energy manifest after? In the motion, and the motion of the cars, the movement of the cars, the motion of the cars. Is that cool?
Yeah.
So again, we see stored in the rubber band, motion of the cars. I'm good with that. You good with that? Now, if you played with these cars earlier today, you may have noticed something about them. Okay? You may have noticed something about them. Did you notice that you can send one in and you get... Worst car ever. Okay? And so what we're noticing is that these cars will push on each other, but without actually touching. Do you know how that's happening? Do you have a sense of it? Is it a magnetic issue?
Yeah.
I think it is actually. If I take my giant magnet here, if I take my giant magnet and I move it, okay, it's pushing it away, and if I turn this one around, it can pull it. Is that cool? But the body of the car is aluminum, so it's not attracting the car. There's magnets in the end. Does that seem okay to you guys? So what we're going to do here is we're going to do a demonstration that looks like a demonstration we just saw. Okay? I will do it a slightly different way so they look really similar. But if I push this together without plunging here, if I just push these together like this and let it go, are the cars still going to move apart? All right? Is that basically the same demonstration? Is that cool? Energy stored in the spring, then it's released, or then it goes to the motion of the car. You guys agree with that? So here's a demonstration. You tell me if you like it or not. Okay? What I'm going to do is I'm going to take these two cars and I'm going to push them together like this. Okay? I'm going to push them together like this, and I'm going to let them go. Now, what I'm doing is I'm just moving my hands up. I'm not doing this thing like this. I'm just moving my hands upward. Do the cars move away from each other? They totally do. So in the end, we have some movement, true? The energy had to come from somewhere. Where was the energy stored before I let it go? Check your neighbors now. Where was the energy stored before I let it go? Check your neighbors now.
And magnets.
All right, energy cannot be stored in the magnets themselves because the magnets themselves have not changed in any way. Right? When we store it in a spring or a rubber band, we know it's stored in the rubber band because we can see some actual change. Right?
He's obviously some word I don't know yet, but
Alright, Justina, let me show you the demonstration. Ready? So, in the original demonstration, I have the spring car and the regular car. And when I push them together and let them go, they move away from each other. The energy is stored in the spring, and then we see it in the movement of the cars. In the second demonstration, I'm going to push these together like this, and I'm going to let them go, and they move away from each other again. But there's no springs here. So we know the energy had to be stored somewhere for these two to move away from each other. Where was the energy stored? That is the question you're working on. All right? Now, the answer to this is super sciencey. Okay? It's not something we've talked about in here, but there's something that you may have had experience with previously. Would someone like to bravely float a guess as to where the energy might be stored?
We said the same thing, but we weren't sure what that even meant. So.
All right, hand up, you and your table maybe came up with magnetic field. Okay? That's great work. All right? So this is the moment where we're like, man, what on earth is a magnetic field? Because if you've heard the word magnetic field, I don't know what a magnetic field is, but might it be possible that it stores some energy here? It might be on your original board. You guys came up with magnetic energy, right? So this might be an actual thing. What if that's a plausible explanation? That seems okay to me. You guys like that one? So let's store that for now. Energy pun. Let's store that for now, and then let's see if that makes some sense given a couple other demonstrations. Does that seem okay to you guys? See, the thing about magnets that I find really interesting is that, as we saw with this demonstration, a magnet doesn't need to touch to exert a force.
Well, what's a force? We haven't talked about one.
Totally. And you're right, we haven't. but I'm gonna rely on your current gut understanding of forces. Because when we start talking about forces, we have to get a board out and be like, what's your definition of force? And let's give some force examples, and that takes like a half an hour. No, who's got time for that today? Okay? But is it possible that this can interact with this without touching? That to me is like super spooky. Okay? That is a spooky, spooky, spooky thing. How can it push without touching? Right? It can pull without touching. Whoa! Right? It can pull without touching also, which is totally a wacky, wacky, wacky thing. I'm just going to make myself at home in your classroom, if you don't mind.